to lecture 22S. So this lecture is a supplementary lecture for lecture 22. And here we will talk about the classification of edges with respect to a certain graph traversal algorithm. So here, let us recall that at the end of a BFS method running on the source vertex S, we would obtain a BFS tree rooted at S. Okay, so the BFS tree is like this. So U is the parent of V in this tree if and only if U discovers V in the BFS. So this was a particular BFS tree when we run the BFS on this S in the previous example. And now all the edges that is in the original graph. So in the original graph it may contain many more edges, but all the edges in the BFS tree in the original graph, we will call them tree edges. Now when the graph G is directed, we can classify each of the non-tree edges UV in the following three types. So the first one is called back edge. So first of all, the following non-tree edge. So tree edges are already classified. So we look at the remaining edges. So non-tree edges, so it can be back edge. So what is meant by back edge? So back edge is an edge that points from a descendant to an ancestor. So in that case, if V is an ancestor of U, then the edge is pointing from U to V, right? From a descendant to an ancestor. So in that case, we go back. So it is called a back edge. Okay, another case is it could be a forward edge. So in that case, U is an ancestor of V. So we are still pointing from an ancestor to some descendant, but this is not the direct descendant. So this is not the direct child. So in that case, the edge, we will call it a forward edge. And if it is not the back edge, and it is not the forward edge, and also if it is not a tree edge, then we will call it a cross edge. So the cross edge is the case where U and V, they do not have any ancestor and descendant relationship in the tree T. So for instance, let's look at this example. Okay, suppose that this is the red edges corresponds to the BFS tree. And let's say we have in the original graph, there are a few more edges. So if there is this edge, then in that case, this edge is pointing from S to V, but S is an ancestor and V is a descendant. So this is a forward edge. But if we have an edge from V to S, then in that case, pointing back. So this is a back edge. And then R to W. So if you look at this, R and W, they do not have any ancestor and descendant relationship. So this is called a cross edge. So S to Y, so here, this is like from an ancestor to a descendant. So this is the forward edge, this edge, cross edge, and this edge, back edge. Okay, that was about the case for the directed graph. But we can also do something similar when we are looking at an undirected graph. So for undirected graph, the edge, there was basically no direction at the beginning. But what we are going to do here is that we will try to give direction to an edge. Okay, we will orient an edge UV as pointing from U to V if U tries to explore the edge before V does. So U is going to see this edge before V sees this edge. So in the BFS algorithm, U is actually processed or visited first than V. Okay. Now, consequently, each edge will now become directed, and then we can use the same classification method as before to classify the edges. Now, there is one question for you. So assume that G is undirected and connected. Okay, so we have undirected graph G, and then we have a connected. So every vertices there is a, so it just have one single connected component. Okay. So we want to ask, are there any back edges in this example. So can we have any back edge? So yeah, think about this. Okay. Now, BFS is just one type of graph traversal. As we have mentioned before, we are going to talk about two graph traversals for this class. So another one is called the DFS that we will introduce soon. Now for the DFS method, it will also define a tree called DFS tree. So again, this DFS tree is based on how we explore each edge one by one. Okay, so in that case, the original edges in the graph can be classified again into four types: the tree edges, the back edges, the forward edges, and the cross edges. So in exactly the same manner, whether they are ancestor and descendant in the tree of the DFS tree or not. Okay. There could be other graph traversals. For instance, there could be something like the scan first search traversal and so on and so forth. So corresponding to each graph traversal, if there is a tree that is defined, then in that case, we could always classify the original edges into these four types. So that's all for this supplementary lecture. Thank you.